So in this section, we're going to use the law of cosines, and we're also going to find the area in two different ways. We're going to find the area by using sine, and we're going to find the area using Heron's formula. So we have two ways of finding the area. The law of cosines is right here in all of its glory. If I'm trying to find the cosine of the angle, if I'm trying to find the angle, then I can set it up as cosine of whatever angle I want, and then the other side's squared. Now notice here, this is alpha, so I have minus a squared. That's the only place I see a in that formula. If I'm chasing beta, the only place I see b on the right-hand side is right there, and it's a minus b. If I'm chasing gamma, the only thing I have is the negative c right there. The relationship here, you see c squared, you see gamma. So if you are chasing c, you need the angle opposite c. If you are chasing b, you need the angle opposite b. If you are chasing a, you need the angle opposite a. How are we doing? Doing okay? Cool. So for this one, they're asking me to find all of the sides. I cannot use the law of sines because I have no angle. When you're asked to find all of the angles and you are given only the sides, you start with the largest side first. You start with the largest side first. Otherwise, you may end up with round-off error. Not drawn to scale. 7, 4, 3. However you want to do it. It doesn't matter. It's not drawn to scale. I'm just putting it there so that I can get all the right stuff. I'm going to call this alpha because I'm going out of control. So I'm going to use this formula, the cosine of alpha is equal to. So I'm going to come up here and I'm going to use the very first one. It is going to be, does it matter which one's beta and b? Nope, so let's just label these. So 4 will be b, and 3 will be c, and 7 will be a. Now you can label them however you want. It doesn't matter how you label them. The important part, though, is you always start with the largest side to find the largest angle. That's the important thing, otherwise you get round-off error. So the cosine of alpha is equal to, I'm going to have 4 squared plus 3 squared minus 7 squared all over 2 times 4 times 3. So somebody with a calculator, tell me what you get. -1? What angle gives you -1 when you take the cosine of it? What angle gives you 1 when you take the cosine of it? Do you have a triangle? No. You have a straight line. You have a straight line. So here's the deal. A plus b has to be greater than, strictly greater than, my c value, where c is my largest side. So if c is my largest side, this has to happen or I have no triangle. The two shorter sides have to add up so that it is strictly greater than the largest side. If it doesn't, then you have no triangle. So the two shorter sides, when you add them up, have to be longer than the longer side. The two shorter added up have to be greater than the longer side. Otherwise you don't have a triangle.
So if that's the case, when we look at B, we already determined there's no triangle?
No, because we don't have three sides. We have two sides and an angle. So on B, we're going to use the law of cosines, straightforward. Which one are we chasing? Are we chasing a side or are we chasing an angle? We're chasing a side. And I can't use the law of sines because for the law of sines, I need to have the angle or the side opposite my angle given to me. And I don't have that, so I don't get to use the law of sines. So I am chasing B, so I get beta, or B squared, is equal to A squared plus C squared minus 2AC cosine 10.5 degrees. So somebody with a calculator, tell me what you get.
I don't know what angle that cosine matches to.
Because I see beta, it has to go with B. Alpha and A, gamma and C, beta and B. Yes?
Is it 2.4 doesn't have to be squared?
Oh, yeah, squared, thank you. I said square, but I didn't write the square there. 19.9. 19.9? Can I get a second opinion, 19.9? Second? Okay. But that's B squared. I want B, so I need to take the square root of that. Do I need to put the plus and minus on this? No, because this is a side. It makes no sense to have a negative side. So I take the square root of that, and so what does B equal to? 4.5. All right. Now, can I use the law of sines? Absolutely, because now I'm chasing angles. So now I can use the law of sines because I have the fact that I have my beta and B. So I can do the sine of beta, which is 10.5 over 4.5 is equal to the sine of alpha is over the 6.8. So what I'll put in my calculator is the sine inverse of 6.8, the sine of 10 degrees, 10.5 degrees, divided by 4.5, and that's going to give me my alpha. Question?
So when you're looking for an angle, you have to do the inverse, but if you're looking for a side, you just do sine.
Yeah. And what do you all get for alpha? Anyone with a calculator?
15.9845.
Do you all agree 15.98? Okay. So then what does gamma have to equal without doing any work? $180 minus 15.98 minus the side that was given to me was just 10.5. So what is gamma? Does that make any sense to you? That the largest side, which is 6.8, is not opposite the largest angle? That makes sense to you? No. That shouldn't make any sense to you. Because if I give you a triangle that looks like this, do you all agree that is the largest angle? Do you all agree that this is the largest side? Does it make sense to have 100 and what was 153 be opposite 2.4 when I have 6.8 as a side? No. Do we actually have a triangle? No. We went through all of this work and we still don't have a triangle. I have something, I don't know what, the math works out, but we don't have a triangle. We do not have a triangle. You'd have no triangle, so you'd write no triangle. Okay, please do D and C. We like it when we get the answers right. Okay, let's take a look at C. We're going to set this up with a law of cosines. I'm chasing here. Oh, actually, I don't need the law of cosines. I can go right into the law of sines. The reason I can go into the law of sines is because I have an angle, and I have the side opposite it, so I don't even have to do the law of cosines. I can go right into the law of sines. So I have the sine of pi over 3 divided by the square root of 3 over 2 is equal to the sine of beta over 1. So I have the sine of pi over 3 divided by the square root of 3 over 2. The sine inverse of that gives me beta. Did you all get beta being 90 degrees or pi over 2? So beta is 90 degrees or pi over 2. That means my missing side, or my missing gamma, must be what if I did 90 degrees? So I have 30 degrees or pi over 6. That means my missing side, which is C, must be 1/2. 30, 60, 90 triangle. How was that? Now, on B, I have to use a law of cosines. I always start with the longest side, so I'm going to start with alpha. So I have the cosine of alpha is equal to, it is 9.3 squared plus 8.1 squared minus 12.2 squared all over 2 times 9.3 and 8.1. When you put that in your calculator, what did you all get for cosine alpha? What was the number that came out? 0.0238948. We'll go with there. So that means my alpha is the cosine inverse of that, so 0.02389. So alpha is 88.63, so I'll do 88.6 degrees. So if I already have one of the sides and one of the angles, I usually go right into the law of sines again. So I'm going to do the sine of 88.6 degrees over its side. Remember, we were chasing the largest angle. So over, what's my largest side is 12.2, is equal to the sine of beta, and beta was 9.3. So I have the sine inverse is 9.3, the sine of 88.6 degrees divided by 12.2 degrees, or 12.2, and this is going to give me beta. What do we all get for beta? Does anyone get a beta? Anyone get? Anyone? Anyone? Someone? Matthew?
I got a different estimate points than the ones you're getting for, so I'm writing my numbers are going to be slightly off.
Okay. 49.65, so we'll call it 49.7. So how do I find my last one? Do I have to go through all of the sine stuff? No. It is simply going to be 180 minus the 88.6 minus the 49.7, and my final alpha or gamma, so the one I'm chasing this time, my final gamma is what? 41.7 degrees. All right? The last bit, which is the area of a triangle. Yes?
On the one before that, when you got C was 1/2, how did you know that without doing the cross multiply divide thing?
Because I put a 30, 60, 90 triangle on there. I would have to have done all the work. So I just skipped all the work because I knew it was a 30, 60, 90. I just wanted you all to have the experience of going through the law of sines.
And that tells you what the length is when it's a 30, 60, 90?
Yeah. All right. So the area of a triangle, we have two ways of finding it. The first way is 1/2 the base times the height. Notice, if I have the B here, I'll need the C and I need the alpha. So if I have B and C, I need the angle alpha. If I have A and C, I need the angle beta. If I have A and B, I need the angle gamma. So this is how I'll find the area of a triangle, the base times the height times 1/2. Now we know from yesterday's the height is going to be C times gamma, or C times the sine of gamma, or it could be C times the sine of beta, or it could be B times the sine of alpha. There are so many combinations in here. But the height we found from yesterday, which is one of the sides multiplied by one of the angles, not the angle it belongs to. So the height is always a side multiplied by the sine of an angle, but not the angle opposite that side. And then we just have to multiply it by its base, and the base is one of the sides. Again, not the angle that is given. So if I'm asked to find the area of these, I ask myself, what do I have? I have A, B, and gamma, so I can go right to finding the area by the formula. The formula is area is equal to 1/2. My base, I'm going to call that A, so 12.9, times the height. So I'm going to decide that my height is 6.4, the sine of 13.7 degrees. So this is my height, and this is my base. So somebody with a calculator, tell me what you all get. What do you get? 9.78. And if I had units, I'd put on their units. I don't, so I'm just going to write units squared. Okay?
How do you know which one to pick for the base? Does it matter?
Nope. Does not matter. Now, I take a look at this. I have beta and I have B. I need to do one extra step. I need to either find alpha or I need to find A. Because what I need is I need two sides and the angle opposite one of the other sides not given. So I either need to chase down alpha or I need to chase down A. What do you all want to chase down? Okay. So if I'm going to chase down alpha, I'm going to have to do the sine of pi over 5 over 23.5 is equal to the sine of gamma over the 19.7. I have to do this intermediate step to find gamma, and then I'll find alpha at that point. So in my calculator, I will do the sine inverse to find gamma. Is going to be the 19.7, the sine of pi over 5, divided by 23.5, and And that's going to give me gamma. Somebody with a calculator. What do you all get for gamma? 20.5? So then alpha is going to be equal, and that's what I'm chasing is alpha, 180 minus the 29.5 minus the pi over 5. Were you in degrees or radians? Did you take the pi over 5 and turn it in degrees? Okay. So what is that in degrees then? What is alpha then? 36 degrees? Okay. So now I can use the area formula. The area is equal to 1/2 the base. Doesn't matter what you call the base. 23.5. That's my base. My height then would be 19.7, the sine of 36 degrees. How was that? Yes?
So the 19.7 and the sine 36 are a side and an angle that are not opposite each other?
Yes. Okay. The last one we're going to do is Heron's formula. If you have all of the sides, you will use Heron's formula. Yes?
I keep trying to do that little negative sign to find the
Sine inverse, not negative sine. Sine inverse.
sine inverse to find the angle, and it never spits out the right number.
Okay.
It's always a decimal.
The angle is always a decimal. I wonder if it's the order of operations. See me after class and we'll take a look at what you're putting in. I think it's the order of operations in parentheses and stuff. So we'll take a look at it after class. Okay, if you know all of the sides, you use Heron's formula. It is on the formula sheet. You need to find it. It is on the formula sheet. If you have all of the sides, do not take the time to find the angles. Just go right to Heron's formula. Heron's formula is you find all of the angles, add them up, and divide them by 2. Not 3. 3 is the average. 2 is what you divide by. The proof's in the book if you want to read through it. It's delicious. If you're having a hard time sleeping tonight, read the proof. It'll be right to sleep. Anyways, moving on. Notice that I take the s and I subtract off each of the sides, and then I multiply that by s, and then I take the square root of it. So let's go ahead and do one. So the first thing I'm going to do is I'm going to find s. This is going to be 16 plus 9 plus 10 divided by 2. 17.5. My area is going to be equal to the square root of 17.5, 17.5 minus 16, 17.5 minus 9, and 17.5 minus 10. Round to one decimal place. 40.9? My units squared. How was that? Fast and quick? All right. That's it. That's it. Test is tomorrow, or test is Monday. Test is Monday. Have a great day. Have a great weekend.